Have you ever wondered how engineers decide the pulley diameter and belt section when designing a V-belt drive? Today, we're going to decode V-belt design, step by step, from pulley diameter selection to choosing the right belt section so you never get confused again. Let's make mechanical design simple with SimpleGAN. Light bulb. V-belts are one of the most commonly used power transmission elements in industries, from fans and compressors to conveyors and blowers. The V shape of the belt increases friction with the pulley groove, giving better power transmission and less slip compared to flat belts. Before we select the pulley diameter, we need to know the speed ratio between driver and driven shaft. The formula for speed ratio is speed ratio equals N1 divided by N2, which also equals D2 divided by D1. Here, N1 is the speed of the driving pulley in RPM, N2 is the speed of the driven pulley in RPM, D1 is the diameter of the driving pulley, and D2 is the diameter of the driven pulley. For example, if a motor runs at 1,440 revolutions per minute, and we want the driven shaft at 720 revolutions per minute, the speed ratio, I, is 1,440 divided by 720, which equals 2. This means the driven pulley should be twice the diameter of the driving pulley. Every V-belt section has a recommended minimum pulley diameter to avoid excessive bending stress and belt wear. Here's a quick guide to typical minimum pulley diameters for different V-belt sections. An A-section belt requires a minimum pulley diameter of approximately 80 millimeters. For AB section, the minimum diameter is around 125 millimeters, while AC section needs about 200 millimeters. Larger D and E sections require even larger minimum diameters, approximately 355 millimeters and 500 millimeters respectively. So, if you select AB section belt, your driving pulley must be at least 125 millimeters in diameter to ensure optimal performance and longevity. Belt section is chosen based on the power to be transmitted and the speed of the belt. Here's a look at the typical power capacity per belt for different sections. An A section can transmit up to about 3.5 kilowatts, while AB section handles up to approximately 15 kilowatts.
For higher power, AC section can manage up to 45 kilowatts, and D and D sections are designed for heavy-duty applications.
As a rule of thumb, use A or B sections for small machines and B or C sections for medium power transmission. For heavy power requirements, D or E sections are the appropriate choice. So, if your motor is 5 kilowatts and running at 1,440 revolutions per minute, a B section belt is often perfect. Once you know pulley diameters and center distance, you can calculate belt length using this formula. The belt length L equals 2 times the center distance, C, plus 1.57 times the sum of the large and small pulley diameters, D and D. Then, add the square of the difference between D and D, all divided by 4 times C.
Let's quickly recap the essential steps for V-belt design.
First, find a speed ratio between your driving and driven shafts. Next, choose your pulley diameters based on the desired speed and ratio. Then, select the appropriate belt section according to the power to be transmitted and the RPM. Always check the minimum pulley diameter to prevent premature belt damage. Finally, calculate the belt length for proper installation. Pro tip: always use IS/ANSI tables or manufacturer catalogs for accurate values.
If you found this breakdown useful, don't forget to like, share, and subscribe to SimpleGAN for more easy-to-understand mechanical engineering content.
Drop your doubts in the comments, and I'll make a video on that too. Until then, keep learning, keep designing. Flex biceps, writing hand.